As we continue into our journey of chemistry, we're going to gain more and more appreciation for the periodic table of elements. We're going to realize that it gives us all sorts of insights about how different elements relate to each other. And we're going to talk about one of those insights, and that's atomic radii trends. So we're going to talk about, by looking at the periodic table of elements, can we deduce how the different sizes of these atoms might relate to each other? So let's just start with the group 1 elements right over here. So we're in this first column. What do you think is going to happen to the radius of these atoms as we go down this first column, as we go from hydrogen to lithium, sodium, potassium, so on and so forth? Well, you might be thinking, well, as we go down this, we're adding a lot more electrons. The outermost electrons, even though we have the same number of valence electrons, we have one valence electron for everything in group 1, that one valence electron is at a higher and higher energy level. It is at a further and further out energy shell. And so one way to think about it is, if you have the nucleus of an atom here, and you have that one valence electron out here, well, the more that you go down this group, you're going to have more electrons in between, this is a pretty messy drawing, in between that nucleus and that valence electron, and that valence electron is going to be further and further out because it's at a higher energy level. So because of that, one, you have shielding from these inner electrons from that positive nucleus, and this is at a higher and higher energy level. As you go down this group, the radius increases. So let me write that down. Increases. What are we talking about? We're talking about atomic radii increases. So for example, cesium, or let's go with francium. Francium is a much larger atom than hydrogen. Now what happens if we were to go horizontally? What happens if we were to go across a period here? So let me do this in a different color. What if we were to look at, say, period 4, and if we were to go from potassium to the right all the way to krypton? What do you think is going to happen here? Think about it for a second before I explain it to you. All right, so this is a situation where we're going to keep adding electrons as we move to the right, but you're not going to be adding electrons to higher and higher energy levels. You're either going to be backfilling in the transition elements, or you're going to be adding electrons to your valence shell. So you're not having higher and higher energy electrons, so they're not going to be any further away from that nucleus. But as you go from left to right across one of these periods, you're adding protons. So you're making the center of that atom more and more positively charged. So it's going to pull in those outer shell electrons more and more and more. So based on that, you would expect to see that the radius decreases as you go from left to right along the periodic table of elements. And we can confirm this intuition by looking at this plot here. So what this is doing is it's plotting every element in the periodic table of elements based on its atomic number and its atomic radius. So for example, this right over here is hydrogen, and then your atomic number increases, you're at helium, and our intuition is correct. It looks like the radius has decreased. And then we go into the second period. And actually, let me just show each period here. So if we go into period 2 here, lithium has the largest radius, and as we go from left to right in period 2, we get to smaller and smaller radii. Now, if we go to period 3, we see the same trend again. So we see confirmed in the actual data that trend, that as you go from left to right on a period, the radii, or the radius, decreases. Now let's think about a group, which is where we started. Well, across or up, down any group, if we go to group 1 right over here, we see that intuition. You go from hydrogen to lithium to sodium to krypton, all the way to cesium here. We have our radius is increasing as we're adding higher and higher energy shells. You see the same thing with group 2. This is the second column in the periodic table of elements. So the data confirms our intuition.